So here we're going to look at the 2016 Maths Leaving Cert Higher Level Paper 2, and we're going to look at question 7. Now this is to do with a glass roof lantern in the shape of a pyramid, and it has rectangular base CDEF. So CDEF here at the bottom. Its apex is at B, and the vertical height of the pyramid is AB. A is the point of intersection of the diagonals of the base, and CD is 2.5. So CD is 2.5 and CF is 3 meters. Now also, of course, here this is going to be 3 meters over here as well, and that's going to be 2.5 along here as well. Okay, show that AC is 1.95 meters. So this distance here, we've got to show that that is 1.95 meters. Well, what I'm going to do here is use the fact that the diagonals of a rectangle will bisect each other. So what I'm going to do is use Pythagoras' theorem. This is a right angle triangle here. I'm going to use Pythagoras' theorem to find the distance CE, and then just simply divide by 2 to find AC. Okay, so let's just do that. So we know that 3 squared plus 2.5 squared will give me the distance CE squared. Okay, so that will give me 9 plus 6.25. Give me CE squared. That will give me CE squared. So CE then is just going to be, add these, divide by 2, you get 3.905, 3.90512, and then that's the distance from C to E. So the distance from A to C is just going to be half of this here, which is 1.95 meters. And that's two decimal places. Okay, so that's it really. Let's move on then. Now we know this distance here. We know this distance here is 1.95 meters. Okay, the angle of elevation of B from C. So the angle of elevation of B from C, so we're looking up here. So this angle in here, in other words, this angle in here is going to be 50 degrees. BCA. BCA is 50 degrees. Show that AB, so the height here, is 2.3 meters correct to 1 decimal place. Okay, so let's just draw that out first, and then we'll work through it. So I just change color here. So we got a triangle like this. It's going to be a right angle triangle again. We're looking at this triangle here, CBA. Okay, so let's say C is here, A is down at the bottom here, and B is at the top. We've just worked out that AC is 1.95 meters. Let me just move that up a little bit. This is 1.95 meters. We want to find this distance here, and we know that we're told that this angle here is 50 degrees. Okay, so what we're going to use here is tan of 50 degrees. So if we write down tan of 50 degrees is equal to the distance AB divided by 1.95. So that just gives us the distance AB is going to be 1.95 times the tan of 50 degrees. So if we do that, we get a distance AB. The distance AB is equal to 2.3 meters. And again, that's two decimal places. Okay, so that's it. So now we have the height here is 2.3 meters. So this here is 2.3 meters high. Okay. Let's move on then. Find BC correct to the nearest meter. Find BC. So where's BC? Okay, so we're going to look at this distance here from B to C. From B to C here. Okay, so look again, we have a right angle triangle here. So we've got BCA. We know the height is 2.3. We know this distance here from A to C is 1.95. So again, we just apply Pythagoras' theorem. That will give us this distance here. Okay, so that's all I'm going to do. So let's just do that here. We're going to take 1.95 meters squared plus 2.3 meters, and we're going to square that, and that's going to give us BC squared. So that will give us 9. We do all of this, you get 9.0925. So that's BC squared. So that gives us BC. The distance BC is just the square root. So that's going to be 3 meters, and that's to the nearest meter. Okay, to the nearest meter. Okay, so now we have BC. So if you actually look at this, and this might be useful later on, BC is 3 meters. So this distance from B to C is 3 meters. That's 3 meters, so this is going to be 3 meters here. So this triangle over here on the left, and indeed this one on the right here, because symmetrical, this is an equilateral triangle. So that's 3, 3, 3. So the angles here are going to be 60 degrees. So I think that's going to be useful later on. Let's just have a look anyway at the next question. Find the angle BCD. The angle BCD. So let's have a look at where that is. BCD. Okay, so we want to look at this angle here, BCD here. So we want this angle here. Okay, so we know that that's 3, we know that this is 3 here, and we know that this is 2.5 here. We've got to work out this angle here. So BCD. So if I was to draw that, I'll just draw it out down here. Okay, so we have a triangle that looks something like this. We know that this is 3 meters. This is B, by the way. This is C, and this is D. This is 3 meters. And down here we've got 2.5 meters, and we've got to work out BCD, the angle BCD. We've got to work out this angle here. Okay, so look, we have the 3 sides of a triangle. 3 sides of a triangle. It's not a right angle triangle, so we can use the cosine rule here. So we want to work out this angle here. So we're going to start with its opposite side here. So we're going to start with 3 squared is equal to, and out at the end here we'll have cos theta. Okay, so this is equal to this squared plus this squared. So 3 squared plus 2.5 squared. And then it's going to be minus twice 3 times 2.5. And then the cosine of the angle opposite this side here, which is theta. That's what we got to find out. Okay, so that's it. That's your equation. So you just got to solve for theta. So we've got 9 is equal to 9 plus 6.25 minus 15 cosine of theta. Okay, so look, you end up with, well, 9 over here. That will just give me 0. I'll then bring this over as well. I get minus 6.25 is equal to minus 15 cosine theta. So that will give me cosine theta is equal to 6.25 over 15. So I got to get cosine inverse of that. So I got to get cos inverse of 6.25 over 15. And when I work that out, to the nearest degree, I get 65 degrees. 65 degrees, okay? So this angle here is 65 degrees to the nearest degree. The nearest degree, that's what we were asked to do here. Okay, perfect. So let's move on to the next one. Find the area of glass required to glaze all 4 triangular sides of the pyramid. Give your answer correct to the nearest meter squared. So if we look at our, if I go all the way back up to the top here again, if we look at our shape here, we've got this area here, and there are 2 of those areas, one here and one at the back as well. We've got this area here, which is our equilateral triangle, and we've got another one over here. So I'm going to find the area of this side here first, then I'm going to find the area of this side here first, add them, and just double it, because there are 2 of each of these. So in order to find the area of this here, I'm just going to use half AB sine C. Remember, I have this angle here now, I have this side, and this side. Now, I know when I'm working out the area of this side here, I can use the same thing as well, half AB sine C, because each side is 3, and the angles in between, because it's an equilateral triangle, is 60 degrees. So this is 60 degrees, I've got 3 and 3 here. This I think I worked out as 65 degrees, and I have 3 and 2.5 here. Okay, so let's work through that. Okay, so let's take first of all the area of, we'll take CBD first. CBD, the triangle CBD. That's the one we've just worked out. That's this one here. Okay, so I'm going to multiply 3 by 2.5. That's half AB sine of this angle here, which is 65. So the area is going to be, what we're going to do is half A, which is 2.5, B, which is 3, and then sine 65 degrees. So again, that's fairly straightforward calculator work. So you just get 3.3987 centimeter, no, it's not centimeters, we're talking about meters here, so it's going to be meters squared. Okay, so I need to double that, but I won't double it yet. I'll do the other one first. We'll do the area of the other triangle then, BFC. BFC, this is our equilateral triangle. So that's just simply going to be half 3 times 3, and remember our angle here is just 60 degrees. Multiply all of that out and you get 3.8971 meters squared. So the total area of glass then, the total area of glass is just going to be equal to twice 3.8971 plus 3.3987. We just got to add those two and double them, and you end up with 14.5916 meters squared. What were we asked? Give your answer correct to the nearest meter squared, so that's going to be 15 meters squared. And that's all we were asked to do there, so that's fine. Let's move on. Next one. Okay, so we have another roof lantern now, and this is in the shape of a pyramid, but this time it has a square base. It has a square base. One thing you got to remember about squares is that, I think it's going to be useful in this particular one. Whoops, what have I done? If you take a square here and you take the diagonals of a square, also bisect each other as with the rectangle, but also you got to remember here that this angle here is going to be 90 degrees. These four angles here are 90 degrees. Okay, so I think that's going to be useful later on. Let's have a look anyway. Now the vertical height AB is 3 meters. So let's have a look at that. So this is 3 meters here, vertical height. Where A is the point of intersection of the diagonals of the base as shown. The angle of elevation of B from C is 60 degrees. So this angle in here is 60 degrees. So that's handy as well. Okay, so BCA is 60 degrees. Find the length of the side of the square base. So we got to find this side here, or this side here, or this side here, this side up here as well. Okay, in the form square root of A. Meters, where A is a natural number. Okay, so how am I going to do this? Well, first thing I'm going to do is, I'm given this side here and I'm given an angle here, so I'm going to find AC first. Okay, I'm going to find AC first. So let me just redraw that triangle first of all. So let's see, I've got a triangle that looks like this. It's going to be a right angle triangle again, and we have C out here, we've got A here, and we've got B up here. We've got an angle of elevation here of 60 degrees, and we have 3 meters here. Well, to find CA again, I'm just going to use tan 60 degrees is equal to 3 over the distance AC. So that will give me the distance AC then is just going to be equal to 3 over tan 60 degrees. And we know, remember, our answer needs to be in the form square root of A. So I'm going to leave anything I get in third form if possible. So let's take AC here then is just going to be 3 over the tan of 60 degrees is actually square root of 3. Now remember, the 3 is just on the top here is just root 3 times root 3. We've got a root 3 on the bottom, so we just end up with root 3. So the distance root 3 meters is the distance AC. Now why is that useful? Well, remember I said earlier that we've just worked out this distance here. This is our square here, and this is A here, oh sorry, this is C here, this is A here, and this is D, looking down on this square base. So we've just worked out that this distance here is the square root of 3. So this distance here must be the square root of 3 as well, and remember this is a right angle triangle. So we were asked to find the distance CD, the side of the square base. So this is just the direct use of Pythagoras' theorem here. So we have a right angle triangle. We have a right angle triangle again. I'll just draw it like this. We have root 3, we have root 3, and we've got to work out this. This is the side of our square base here. So let's do that. Square root of 3 to be squared plus square root of 3 to be squared. That will give us CD squared. This distance along here squared. Okay, so let's do that. That will give us 3 plus 3 is equal to CD squared, so that will give us CD. The distance CD is, this is 6, so it's just the square root of 6, and that's meters as well. So the side of our square base is the square root of 6 meters. And that is it for question 7. Okay.